Hey, I'm Henrik Mårtensson, and this is a presentation about Agile requirements and why Agile requirements must be vertical slices of functionality. Let's begin with a description of stories in SAFe. Now, there is an extremely important part that is often overlooked, and it's this. Stories are short, simple descriptions of functionality, usually told from the user's perspective and written in their language. Each one is intended to enable the implementation of a small vertical slice of system behavior that supports incremental development. And now we look at why this is important. Back in the 80s and early 90s, finding out what users wanted was a major problem in software development. Corporations were designed to put up barriers between different parts of the organization and between the organization and the outside. Requirements were written by requirements engineers who had little or no contact with users. Each requirement described a functional part of the application. Each function was developed by a developer working in isolation from others. Developers got requirements with defined inputs and outputs, but very little context. They created building blocks, but didn't know what they were building, and that could get confusing. So in the early 90s, I worked as a technical writer, and once I interviewed a developer and found that the technical specification did not match what he told me he had built. He had confused the inputs with outputs and built the whole functional unit so that it worked backwards. Now, these kinds of problems and spending tons of money on useless software features, that was actually a common problem. One thing that happens when each team works on a function is that the velocity of all the teams as a whole goes down. For example, in this simulation, 4 teams working on functions could complete 4 stories in a sprint. Note that given the same velocities for each team, if each team built something end to end, they would have completed 5 things instead of 4. Thus, functional requirements makes teams and developers lose context and also reduces their velocity. It also makes it very difficult to create good designs. You can't fix bad initial assumptions because of the dependencies on other functional units, so it's difficult to change as you learn more. Now, some developers got tired of this. They invited users to sit down with developers and talk about what they wanted. Users wrote down small stories on index cards telling what they wanted to do. You got the voice of the user and the language of the user because the user wrote the requirements. This way, the developer or developers that work on a story do so all the way from the user interface to the business logic to the database. With microservice architectures, we have gotten new design patterns that enable vertically sliced microservices. Now here's a different view of the same thing. Note that because the teams are working independently of each other, the total velocity in stories per sprint is the sum of the velocities of their teams. Now, if we start splitting stories into functional pieces, these pieces will then be developed by different people in a team or in different teams, and then everyone gets dependent on everyone else. This is a team dependency map with the teams removed from a real project that had similar problems with requirements. The functional requirements were distributed among teams, which caused unnecessary dependencies. The requirements were not the only problem, but they were one of the major causes of delays. In this particular project, despite having 20 agile teams that each delivered every 2 weeks, The project did not deliver any working software for 30 months. Notice how even if there are no dependencies because tasks if there were no dependencies, because tasks from different vertical slices are interleaved, lead times expand, teams are forced to multitask. This is data from a project where the team worked with stories that were vertical slices and each developer worked with a story end to end. Then, management decided to speed things up by hiring more developers. They hired front-end developers, so the original developers became back-end developers. Now, stories quickly morphed into functional descriptions. The natural variations in velocity of the two sub-teams pushed development out of sync and velocity dropped like a rock. This was with two interdependent sub-teams. This is from a team going in the other direction. From week 35 to 40, the team worked with interleaved tasks. Week 41, we reorganized and the team could focus on finishing one job at a time. Now, in this particular case, we could determine exactly what the change was worth. Now, this was in 2008 during the global recession, and the company was going to fire the developers. Thanks to the increase in productivity, they could land a major contract worth a total of 400 million crowns, Swedish crowns, and no developers were fired. So, what do Agile requirements look like in practice? Let's start at the epic level. Here's a business epic. And this is what it looks like in its simplest form using the Leffingwell requirements model. It's the same model SAFe uses per default. So as you can see here, there isn't really much to it. There's an entry date for when the epic was, when we started to develop the epic. There's an epic name. There's a dedicated epic owner, a description, a very short description of the epic. And there is also a expected business outcome. Sometimes there may be something called leading indicators if this is something new that we expect to have a particularly high business value. We have also listed some non-functional requirements like door lock cycle time and alarm sound level, and these would be detailed in other requirements. There's also, if you work with SAFe, you also list the Agile release trains, the ARCH involved. A business epic has a number of user features. According to Leffingwell, you should never need more than 50 user features to describe a system. These user features are also called business features. And in this particular case, we have three of them: a remote control, a door lock, a service cover. Now here's a user feature, and in this case, for a remote control. So there is a feature description, a benefit hypothesis that tells what benefit the user will derive from the feature, and then there are acceptance criteria. Now, a feature also has user stories. For example, in this case, as a truck driver, I want to lock the doors so they do not open while I'm driving. Notice that there is no design, no interaction steps or anything like that. All that is deferred for later. It's important, but not right now, later. This feature has a couple more stories. For example, as a truck driver, I want to unlock the driver door so I can get into or leave the truck. As a truck driver, I want to unlock both doors so a passenger and I can get into or leave the truck. And as a truck driver, I want to activate the panic alarm so I can get help in an emergency. And finally, as a truck driver, I want to deactivate the panic alarm when an emergency is over. Our user story is broken down into tasks. In a small project with a single team, that's all there is to it. In a large project, it gets way more interesting. A team that owns user stories is called a stream-aligned team or a value stream-aligned team. In a large project, that team needs help. For example, by enabling teams that look at the user story breakdown and take responsibility for building subsystems. They describe these subsystems using enabler stories. A complicated subsystem team is a specialist team that builds subsystems that require some special knowledge. And then at the bottom, there are platform teams responsible for the platform and enabling everything else. Mm. So, as you can see here, the team topology, the organization of the teams, is important and it's related to the structure of the requirements. It's also related to the architecture of the application, of course. So, uh, and teams are mainly organized in SAFe. They're organized in Agile release trains, arts. Some teams span over more than one art, but most are part of just a single art. And finally, the way we use to check that we actually have implemented a user story is the solution demo in SAFe. Here we demonstrate fully functional working software. No PowerPoint, no, no long-winded presentations. We focus on working software. And you can often tell if a project or SAFe program isn't working quite right, because then they won't have anything to present on the solution demo. So what they usually do is they make PowerPoint presentations or something like that instead to replace the software demonstrations. You might want a bit of further reading. I would recommend the following books: Agile Software Requirements, Lean Requirements Practices for Teams, Programs, and the Enterprise by Dean Leffingwell. Uh, Writing Effective Use Cases by Alistair Coburn. And the use case book is mainly for larger projects, actually. And then about UX design, About Face, The Essentials of Interaction Design by Alan Cooper. Thank you for joining me in this exploration of the depths of Agile requirements management. Even though there are difficult problems, I do believe there is light at the end of the tunnel if we are bold enough to venture there. So thank you very much.